Okay, dear students, let us see what is there in this question. A rectangular coil of wire RSTU is connected to a battery and placed in a magnetic field Z directed towards right. Both the plane of the coil and the magnetic field direction are in the same plane, as shown in the figures, quite clear. What is true about the magnetic force that is acting on the side RS and ST? So, where is RS? This is RS and this is ST. Okay, here and here. Okay, fine. So first of all, we have to see how the battery is connected in this question. You see, battery is connected like this. So obviously the current will be moving like this. Okay, so first of all, we have to show the direction of current. Okay. So this is the direction of current. Now we want to find the force that the magnetic field will be applying on the wire, and how do we do it? Well, as in many other videos I have given earlier also, that I do not use Fleming's right hand or left hand rule. Instead of that, I prefer using right hand palm rule. Right hand palm rule. So, in right hand palm rule, how do we apply? I have given a dedicated video for right hand palm rule because it is of three types: type 1, type 2, and type 3. And I have discussed it in complete detail, and that video is available on in the playlist for this topic. That is 5.4, I think. Yeah, there. So you go there and you see there, this method is far better than any other method, and you will never be having a problem in these kind of questions ever again. I promise you that. Watch that video. Okay. Now, in this question, in I use the right hand palm rule. This is the right hand. So what happens is my fingers will be pointing towards the magnetic field first of all. So fingers are towards magnetic field. Thumb is pointing towards the current, the direction of the current, and the palm will be pointing towards the force. Palm will be pointing towards the force, and this is what we want to find. This is the right hand palm rule. Very easy, you see. This is the palm. Now let us concentrate on the wire SR. So where is the magnetic field? The magnetic field is towards right. So I'm keeping my hand like this. And where is the current? Current is in the opposite direction. So it's like this. Current is in this direction. You can't see my face, but you can see my hand now. And these fingers are towards magnetic field. So where is the palm pointing towards? So palm is coming out of the board, isn't it? So it means that this RS will be experiencing a force out of the book, out of the page. So out of the page is there in the option, so B or D. So half part of the question is done now. And force acting on ST. Now ST, because the angle between the wire and the magnetic field becomes zero. So what is the formula? The formula is B I L sine theta. If you remember, BIL sine theta. So B is the magnetic field, I is the current, L is the length of the wire, theta is the angle between the wire and the magnetic field. So what is the angle here? This and this, you can call it like 180 degree, or you can call it 0 degree. In both of the cases, sine 0 as well as sine 180 is 0. So what is the force that is acting on this wire? So I will say that the force F on ST has to be 0. So no force. Definitely your answer is going to be B in this case. Do you get it? Like, there are some students, those who say that the force on TS would be 0 because there is no magnetic field on it. Anyways, whether there is a magnetic field or whether there is not a magnetic field, if the wire is having the same direction as that of magnetic field, whether the magnetic field exists or whether it does not exist, anyways, the force is going to be 0. So my dear students, the answer is going to be B. All the best. Bye. Please subscribe to the YouTube channel and share the YouTube channel with all your friends.